Hey everybody, welcome to Interactive Stargazing. My name is Wesley Sonamaker. I am here tonight with Claire Gibson. Say hi, Claire.
Hello.
We're right now looking at a picture of the Orion Nebula. This is a giant cloud of gas out in space that's having new stars born inside of it. What else is neat about the Orion Nebula, Claire?
I really like all of the colors that we can see with the camera. I always think something that's really cool is how different an object looks in the telescope versus through a camera. Our eyes are bad cameras, basically, and I like to see pretty colors. So I like this about the Orion
Human
Nebula.
eyes very good for finding berries on trees, not so good for seeing giant clouds of gas thousands of light years away from us.
Exactly, definitely.
Much less good at that. So this kind of nebula is actually being illuminated from light from the stars that it's made inside of it. And so a little bit ago, I think the stacking has updated, so you can't quite see it in as direct detail anymore. But a little bit ago, you could see the sort of four brightest ones in what is now that big giant bright area over there. And that's what's making most of the light in there. It's really pretty. Oh, there we go. Look at that.
So we're lowering the exposure on the camera so that we can get those stars right in the middle that were overexposed when we're trying to look at that nice pretty gas. So those are the stars that are actually illuminating the nebula from the center. So we get the
best. These ones you can see in the night sky. You can see those like four ones as one little point. It's really tiny, but you can see it with your naked eye. The giant gas cloud around it, not so much.
Yes, very true. But we decided to start off with the Orion Nebula because it's setting, and so we wanted to show you before it dips below the trees, but I think we're ready for another object. We're kind of moving out of the winter season and into the spring season for some exciting objects, finally. So we're finally getting into galaxy season, which is my favorite. So maybe we can look at a galaxy. Which one do you want to go to, Wesley?
Oh gosh, what's good right now? Do we have M51 yet? That's my favorite. I'm not sure if it's quite late enough at night that we can see it quite yet.
We'll have to wait. But let's try.
All right.
Okay. We have received confirmation that we can, in fact, see this.
Oh.
So we're going to see probably one of the best spiral galaxies that we can see from Earth, which is
my favorite thing to see at all. This is my favorite object in the night sky. It's really, really gorgeous.
Yeah, the M51, or as it's also known as the Whirlpool galaxy, is so spiral in its shape that it's called a grand spiral galaxy, because saying spiral galaxy is just not enough to describe this galaxy. It has to be a grand spiral galaxy. And I think that's true.
Yes, yeah. I would totally agree, especially for this one. This one's really cool. You can start to see those two main points of light in there, and those are the centers of these two different galaxies. There's actually two galaxies we're seeing here. One of them is eating the other one. M51A is pulling it, sucking all of the stars in M51B into its core. And eventually they'll sort of crash together, and they'll make one big galaxy with more stars in it than it used to have. It's called galactic cannibalism. It has a very scary name, but it's not actually a very scary process because nothing actually crashes into anything else.
And also it takes like millions of years to happen. So
it's very slow.
Galaxy scale,
very slow.
Yeah, on the galaxy scale, these galaxies are moving pretty quick, but on our human life scale, it's just like, oh, nothing's happening. So we get a snapshot of this in our lifetime right now. But we can predict what's going to happen in the future. So it's a pretty nice one.
Yeah, it's not too bad.
Yes. And if you're trying to find this with like your own home telescope or perhaps binoculars, an easy way to find it is kind of using the Big Dipper. So technically this galaxy is in the constellation of Canis Venatici, which kind of don't see very well in the sky, but the Big Dipper is a lot easier to see. So you can kind of just go right off the handle of the Big Dipper. So we have the mouse pointing to it, and you just go down a little bit, and then you should be able to see a cool galaxy there. So that's an easy way to find it instead of randomly looking online where it is.
Yeah. I always find that last star in the Big Dipper, Alkaid, and then go just a little bit off of it. to find this thing.
Perfect way to find it. Well, looks like we have some requests in the chat that we can go ahead and go to. So the first one is M65, which is a galaxy in the constellation of Leo. It is part of what we collectively call the Leo triplet, which is a nice collection of galaxies that we can sometimes see all in one frame of view, depending on what kind of camera and telescope you have. Generally, we see two with this type of telescope in camera, the plane wave telescope, the Malincam camera. So we're gonna head over.
I love the Malincam. It's so cool.
It is very nice. I agree. But yeah,
Dulcimer, I always love Ceres. Is Vesta a pre-dawn object? I don't know. Claire, do you know?
What is the question?
Is Vesta a pre-dawn object?
Not always. Right now,
it's complicated, right? It depends what time of year it is and where everything is.
So right now I think it is, because it is in the constellation of Capricorn, but I do recall seeing it not at dawn before. So yeah. But right now I think, yes, that is the consensus. So we have M65 and one of the other Leo triplet galaxies kind of peeking towards the corner. So we can see 2 in 1. This is such a deal. M66, M65, and M66. Two little nice galaxies.
The Leo triplet.
Yes. Yes, we're, again, in galaxy season. We're hopefully going to look at some pretty cool galaxies tonight. We are dealing with a little bit of haze, so some of our photographs might look a little bit interesting. We are dealing with some of that haziness in the sky, but we can still see pretty good, so not too bad at all. But let's go ahead and move to a globular cluster, and a spectacular one up right now is called M3. It is probably one of the best northern globular clusters out there. I don't know.
What is a globular cluster, Claire? You have no opinions on M3. No M3 opinions whatsoever.
No M3 opinions.
Okay.
But I can tell you what
I also have no opinions. So.
Okay.
What is a globular cluster? Yes, please, please.
So
I know it's rare for me to not have opinions on something. But.
It is a collection of usually roughly 300,000 or so stars. Sometimes it can have more. Big ones usually have around 500,000 or 500,000 stars. These stars are really old. Like there's not really any young stars in here. And another interesting thing about globular clusters is that within our own galaxy, we only see about 100 globular clusters, which means they're pretty rare, like considering the whole Milky Way with our billions of stars, and there's only like 100 globular clusters. So those are some tidbits. They are lightly gravitationally bound stars, so they're pretty densely packed. They look like little globs, or kind of like sparkly baseballs out in space, however you want to describe it.
Sparkly baseballs. I don't know that I've heard that one before. That's fun.
But yeah, they're really spectacular to look at. Easy to find with a pair of binoculars or small telescope. And honestly, these are like clues that we can look at as astronomers and researchers to look at what the beginning of the universe was like and what some of the first stars were like in our universe, because they are very, very old, and they're unique to each galaxy. So they're pretty cool.
Yeah, I love them a lot. They're also really neat because there's no planets around any of these stars, because the elements that you need to make rock out of did not exist anywhere in the entire universe when these stars were formed.
Yes, geologists were very sad at this point in the universe. There were no rocks.
No metals, as astronomers would call everything that isn't hydrogen, helium. Zachary Moorbacher asks, what is the most bizarre galaxy out there? One that is nothing like the Milky Way. I don't know. I mean, I could just give kind of a cop-out answer and say, like, the kinds of really early universe galaxies that the JWST is going to be able to look at now. That feels kind of like cheating to say that, though. I don't know. What do you think, Claire?
I can't, like, I have examples in my mind of galaxies that are nothing like the Milky Way, but I don't know what the weirdest one is. I feel like that's very specific, and I don't know what it is.
Right? Yeah. I mean, like, there's lots of galaxies that look very different through a telescope. I don't know. They're all just big chunks of stars. So, like, on some
That's true.
level, they're all kind of the same thing. Gosh,
Very
I don't
true.
know. What do you think? What's the weirdest one you can think of off the top of your head?
So the weirdest one that we can like look at right now is probably M82 because it's an irregular starburst galaxy, um,
Yeah.
and it's just weird. So we can go look at that. So we have a
Gonna
visual.
try looking at M82. Yeah. Yeah.
Yeah.
Yeah.
So it's also called the Cigar
Starburst
galaxy.
galaxies are so cool.
Yes. So this one is weird because one, it doesn't have like a shape, so we kind of just put it into the irregular category. It's just like
I
the
love the
what
irregular
we don't know how to
category.
describe galaxies, we put it into the category.
This one
Um,
looks funny.
and it's a starburst galaxy, which means that as astronomers have looked at this galaxy, they've noticed that there's just so much star formation going on that like it's kind of blowing astronomers' minds, and so they call it a starburst galaxy. It just means it's making more stars than a normal galaxy would, like sometimes up to
Wacky.
10 times more stars, which is a lot of
That's so many
material.
stars.
That's a lot of stars, yeah. So we can see kind of like the central part of the galaxy here. As you can see, it kind of just looks like a smudge out in space, but it's cool. So it's a whole galaxy, about 12 million light years away, I want to say. Yeah.
And there's a satellite, really quick.
Yes, indeed. We might
We'll
see
wait for
more
this
of
next
those.
picture to come up so we can make it go away.
But anyway, this is probably the weirdest one. If you Google Hubble pictures of this, it kind of looks like a butterfly. There's like jets of stuff coming off
Yeah,
that central
it's
axis.
really freaky.
So it looks really weird. It acts really weird. It's cool to look at though, so I think it's pretty good. But anyway, are we ready to move on, or do we want to glance at this more?
Sure.
Okay.
I'm trying to find a link to a good Hubble picture of this thing.
Oh.
It looks very bizarre.
Yes, it does.
Yeah,
Usually the stuff coming off the sides is like very red in color. So you need a really long exposure photograph to be able to get that red color. We can kind of see some of that reddishness in the center part of that galaxy, kind of like those dust lanes weaving into that really bright segment in the middle. But we usually have to take a longer photograph to be able to get some of that deeper detail, especially that red gas. So kind of interesting on how that works. But anyway, this is the weirdest galaxy that I can think of that is within our view. We'll try to get a picture up on the live stream, maybe. Don't know how this works.
Hopefully. I found a link to it. I asked someone who is in charge of our YouTube channel to post it in the... Well, hopefully that'll happen eventually.
Yes. Anyway.
Christmas tree cluster. John S. Asked for the Christmas tree cluster. Can we get NGC 2264, please? Cone Nebula and Christmas tree cluster.
The Christmas tree cluster. I've seen this before.
Mono Ceres.
Yeah. Let's check out the cluster. There's also lots of clusters up. That's pretty average for any time of the year, though. Basically, if you look at the sky with your telescope, you'll probably find a cluster.
There will be stars there.
Yeah.
Some of them will be clustered.
Yes, very true. So let's try this. So this one, don't need a very long exposure. These are going to be pretty bright stars. We should be able to get a nice photograph in a moment. Ooh, look at that. Nice. We even got like maybe some nebulosity question mark. That's pretty cool. Co-nebula, maybe that's part of it.
Ooh. Yeah, that's very pretty.
Very nice.
I guess it's... I don't know if this looks like much of a Christmas tree to me. I don't know if I'm on board for calling this a Christmas tree.
I don't know either. I don't know. Oh, we're drawing it, I guess.
Okay.
Oh, I
no.
kind of. But then the tree is kind of just like very loosely interpreted from the background. I don't know.
Yeah, I don't know. I don't know how on board I am for this.
I'm not sure either. Maybe it looks different through a less zoomed in view where you can see more of the shape.
Maybe.
But anyway, that's
I can sort of get how having one bright star at the top makes it look kind of like a Christmas tree. Like the star on top of the tree.
I can see
but
that.
I don't know about the leaves or the tree part. Well, I guess needles, not leaves.
So there's a little bit of wind tonight too, so you might see the stars kind of like become ovals. That's just the wind moving the telescope around and creating a weird image for us, but it's not too bad, so we can keep going. So we have another request for M87. We can definitely do it. That is probably one of the most famous galaxies out there for multiple reasons, although it looks like a glorified blob out in the sky. But we can look at it. This is M87. It's an elliptical galaxy. So it's an old, developed galaxy. There's trillions of stars in this galaxy.
This is the one where we took a picture of the black hole at the core, right? That's
yes.
This one?
This is indeed.
Super cool.
So there is a supermassive black hole at the center of this galaxy. We can't see it with our telescope, of course, but we can imagine that it's there.
We would need a few thousand more telescopes and to take hundreds of pictures of it for like a whole year. And then we could see it.
Bonus, though, we get some other galaxies in the background. So those like fuzzy looking star things are also galaxies. So we just get bonus galaxies with this, which is pretty nice.
Lots of bonus galaxies. Yeah, the more powerful your telescope is, the
more bonus galaxies you'll get.
Yeah.
One thing about this one as well, I have some information about this.
Oh.
So generally, when astronomers do research, they don't always look in visible light like what our eyes can see. They also look in other types of light, such as radio. And this is one of the brightest radio sources in the sky. And the cool thing about radio astronomy is that you can do it when there's clouds, which is like so nice.
Oh, yeah.
Yeah, so like if you're a radio astronomer, weather just like doesn't bother you too much, probably. At least clouds. I don't really know. I'm not a radio astronomer. You can also do it in the daytime. So like you can just be an astronomer 24/7, which is pretty nice. But this is one of the brightest radio signals from the sky that we can see is M87, this galaxy. So that is pretty cool. I like this one a lot.
It's really neat.
Sweet. All right, I think we have some more questions and what we want to look at. Do you want to read them off, Wesley? There's one of them that I can't read because it's yellow.
Can M101 be looked at? We can try when we get to it. Give it a couple minutes, so we can get to that momentarily. James Hyatt. Do you want to do Cat's Eye Nebula?
Yeah, that sounds good. We did have a request for something called the Aquarius galaxy.
Aquarius? Yeah. Aquarius is a constellation that's not up right now, and we couldn't find anything named the Aquarius galaxy. So if you have any clarification, we can try and help you out with that, but we don't know what that is.
Yes, very true. But let's head over to the Cat's Eye Nebula. It is pretty cool. Oops.
Dulcimerist asks, does this radio object make noises that can be picked up? Not like really.
Yes, but not like with our car radio.
Yeah. You can take the radio signal and turn it into a noise representation, which is already kind of just what your car is doing, but it's not the same like magnitude of radio signal that you get here on Earth. It's very, very different. And so you'd need it to be sent in a little bit of a different way, stuff like that.
It looks like the Cat's Eye Nebula is in the dome update. So let's try M101. It's a little bit windy, so we'll try our hardest. but let us try. But Dulcimerus, that is a great question, actually. Very good question. I wish we could hear galaxies on our car radios. That would be creepy, but cool.
I also wish we could hear galaxies on our car radios.
Creepy, but cool, for sure. So this is another galaxy. It looks like a spiral galaxy. We can kind of see it just a little bit. We should get a little more detail on the next exposure. So we're just waiting to collect more light from this object.
M101. This is one of a couple of different galaxies that's called the Pinwheel, which I always think is fun because astronomers are famously bad at naming things, and this is a great example. There's like 3 or 4 of them that some catalogs will call the Pinwheel. There we go. There's a little more detail.
The Pinwheel galaxy is a very purple galaxy. You can kind of see that purple color, but I think purple galaxies are the best. So go purple galaxy.
They are very pretty. Oh, it's very close to the dome is where all that glare is coming from, evidently.
That is true. So it looks like this is as good as it's going to get at the moment. We can see that bright galactic center. We can see those spiral arms. So pretty good. That's M101. We have another request, which is for NGC 2440, which is a planetary nebula in Puppis.
Ah, Puppis. Yes, the poop deck of the Argo. My favorite constellation.
Who decided on that?
I have no idea. Astronomers continue to be bad at naming things.
Maybe they're also trolling us with that constellation.
You know, perhaps. Puppis. Yes, that one's on the other. Yes, Cody Half Moon. This Whirlpool galaxy is near the tail of Ursa Major, right? Yes, it's on the other side of M51 that we were looking at just a little bit ago. They sort of like are on either side of Al-Qaid, I think is the name of that star that's on the end there.
Yes, I think that's right. Yeah. Ooh, here is this planetary nebula. It looks pretty cute. Oh my gosh. It's like a little bug.
That is very cute. Now, Claire, planetary nebulas are called planetary nebulas because they have something to do with planets, right?
That is incorrect, Wesley.
What do you mean?
Like you said, astronomers can be pretty bad at naming things, and this is another example of this. So planetary nebulas don't have anything to do with planets. This is a very dead star in the sky. Our own sun, in like 7 billion years, will become a planetary nebula as we run out of fuel and just kind of push all of the gas that makes up the star outwards into space. And it becomes this glowing mass of stuff that is a dead star. That has nothing to do with planets. And generally, if there probably was a planet around that star, they're long gone. So
it's probably been destroyed by the giant cloud of exploding star that hit it.
Yes, totally. But yeah, this one's cool. It kind of looks rainbowy to me. It looks like the colored parts look like the wings of like a bug or something. I don't know.
Yeah,
maybe
like a beetle. Well, it's
yeah,
kind of beetle-y to me.
Yeah, the center is really bright though. Yeah, or it kind of looks like a butterfly, but that's just me. Yeah. Oh my gosh, this is perfect. What? It's like a little lightning bug. Cute.
Great. I love it.
So that's a planetary nebula. Has nothing to do with planets. When astronomers back in the olden days were looking at this.
Specifically, the same dude who is responsible for Uranus being named so poorly, who originally wanted to call it George. So.
Oh, are we talking about William Herschel?
I am talking about William Herschel. You can just blame William Herschel for all of your problems. Dulcimerist, is this telescope able to show the separation of the double star in the handle of Ursa Major? Yes. Your eyes are able to show the separation of the double star in the handle of Ursa Major.
If you have good eyes. Hold on.
Yeah, if you have good eyes.
You need to have pretty good vision to do that.
But if you look even closer, yeah, that's all right. That's fair. I can usually barely see them with my glasses on because my eyes stink. But where was I going with this? Oh, if you look closer, you can see that there are even more double stars in there. Yeah,
that's
so
true.
If you go point over at Mizar, there's a Mizar A and a Mizar B. Telescope operator, if you'd point at Mizar, pretty please. Thanks. That's Mizar A and Mizar B. So those are not the two stars that you can see near each other in the night sky. The other star that you can see near Mizar is Alcor over there. Mm-hmm. Really cool. So yes, long-winded way of saying yes.
We have another question, which is, what are the chances of doing an interactive stargazing with a southern hemisphere telescope so we can see southern sky objects that we don't get to see in the northern hemisphere? Consensus so far is we'll look into it. We have no idea, but to me that
we
sounds
don't have any
really,
of those.
That sounds awesome though. We'll look into it.
Very cool. They're all very, very different. There's an entire different sky down there.
Yeah. I would love to do that.
That'd be super cool, yeah.
So I guess stay tuned, perhaps?
We can, Claire, we can just throw one of the portables in a car and then drive all the way down. You can drive over the Panama Canal, right?
That sounds hard.
We just go down. Yeah, no, that'd be fine. I'm sure it'll be fine.
I'm good.
You don't wanna come with?
Like, okay, so I don't think I've even been to the southern hemisphere, like, at all. So, like, I don't know how to find objects in the southern hemisphere. I feel like that would be
been to the southern hemisphere either. Now that I think about it,
that would be a very bad interactive stargazing if we were to lead that.
It'd be terrible.
Yeah.
Yeah, we'd just be like, "Oh, this is cool. Now let me read you the Wikipedia page."
Yeah, very true. But we'll see if that's a possibility. I don't know how long that will take, but that's a great question, a good idea, and we'll keep it in mind. So let's.
Dulcimerist, are the two Mizar a binary, or are they very far apart and just line up that way? The two Mizar are in a system together. They're gravitationally doing things to each other. But Alcor and Mizar, even though they look like they're binary to your naked eye, are very, very far apart.
Good question. I think we can move to M46 next, which is a very nice open cluster with a planetary nebula in it. So we get a 2-in-1
Oh, I love M46. It's so pretty.
Yes.
Yeah, this one's really, really pretty.
I'm excited for this one. I always forget that this object exists, and it's like kind of amazing.
Me too. It's like never in my head for some reason. I don't know why. It's really pretty looking.
It is. It's pretty awesome. So we'll be able to, look at a cluster with a planetary nebula. And remember,
it's like there's one other open cluster that has like a red giant like in front of the open cluster, and I never remember which it is, but it's really pretty.
That's not so
cool. Look at that.
Nice.
Still got some streaky stuff in there from the last exposure. Hopefully that'll iron out when the next one finishes up.
Ooh, perfect.
Most of astronomy is just sitting around waiting. Yes. Oh, look at that. That's really pretty.
I like this planetary nebula because it looks like a Fruit Loop in space.
A Fruit Loop?
Yes. A blueberry.
You know what all the bluish, greenish stuff in there is?
It is elements from that star. Probably.
I've been told it's mostly oxygen.
Yes. Yeah, I was going to say the same thing.
Well, now I look like a jerk. I'm very sorry.
What? No. Some of that, you can see a little bit of that like orange too on the outskirts, which I've never noticed before. I don't think I've like really zoomed into this object, but that's like more of our hydrogen and helium. So that's pretty cool. So you get like different layers of gas depending on how old or how big this star was during its lifetime. So we can learn a lot by looking at the death of a star, which is pretty cool. Let's see. Pretty good. Shall we move to another object?
Yes.
Okay, we have...
Do you want to try Flame Nebula? I think somebody asked for Flame Nebula a while ago.
Let's try it. We're going to try the Flame Nebula.
All right. Go for Flame Nebula.
This is a pretty neat nebula in the constellation of Orion. This one, nebula looks like its name. Looks like a flame. So, pretty spot on with that, I would say.
It does look like a flame. There's some nebulas that are named very, very poorly. This one's pretty good. This is a good one.
I agree completely.
The Swan Nebula is rough. I don't think that one's up right now, but
no, I don't think it's
I've got a bone to pick with the Swan Nebula.
Yeah. That's very true. What else is there? I think the Running Man Nebula kind of looks like what it's supposed to be like. Although it's kind of weird.
Yeah, the Running Man Nebula just looks a little goofy.
Yeah.
It's just strange looking. He's a funny little guy.
Yeah, very true.
I don't know if he quite looks running. I can see the man part, but I don't know about the running part.
What's he running from is the question.
What is he running from? So true.
Okay, here's the Flame Nebula.
Oh, look at that.
We get...
There is something really bright right next to it. What is that?
Yes, there's a very... I think I could be wrong, but I think that's one of the stars in the belt of Orion. Like, we're just off the belt of Orion.
Oh, neato. Oh, so this is in the same
wrong.
molecular complex, right?
I don't know.
Sarah Bircher says, yes, it's the left one. All in attack. That's all in attack.
All in attack.
Of course. How could we forget about all in attack?
I didn't know that was the star name for this. I just say Orion's belt collectively.
Neither, man. Orion's belt. It's one of those ones.
Yes. But anyway, this is a nice pink nebula. A little bit of purple in there too. Looks pretty nice. I like the dark nebula, kind of like that, the dark like stuff bisecting the middle, giving this a nice detailed look. So pretty good.
It's really pretty. It's really, really cool.
Do
you know much more about the Flame Nebula? Do you know what kind of, like, why it's glowing this color?
No. I'm assuming it's mostly hydrogen gas, because that's like...
It's a pretty safe guess.
Like, the whole Orion complex is like the Orion molecular cloud.
It's a ton of hydrogen.
Something like that. Yeah, and it's basically all hydrogen. And so I'm assuming this is more hydrogen.
It seems like a safe bet.
Yeah, and usually hydrogen, it's pretty common to have kind of like that pink color. Like the Hubble Space Telescope photographs for the Orion Nebula is very pink in color. We could kind of see that earlier tonight when we were looking at it with the Planewave telescope. So, yes. But that is my prognosis of this. I don't really know anything other than that, though. We have a comment that it looks like a tree. I think that's pretty good. I like that comment. But let's...
I agree, KDE. It does look like a tree.
We have some more requests, so let's try for M1. This is...
We're going to get a lot of moon.
Yes.
Which means we might as well just move on to the moon. But we're going to try M1 first.
Yeah, let's do M1 first. Let's not jump conclusions to the moon.
Oh, man, the Crab Nebula is not that bright either. This one's going to be hard.
Yes. We'll try our hardest, though.
This used to be a star, and then it exploded, and we saw it here on Earth like 1,000 years ago, and a bunch of people wrote it down in, like, the Middle Ages, and they were like, "Dear Diary, today there's a really bright point of light in the constellation Taurus," and then it was still there for the next, 5 days. I don't know what that was. And then we went back 1,000 years later, and we were like, "Oh, my God, it's a supernova remnant."
Yes. Pretty good. Yes.
Oh, good Lord. Well, we can say something at least.
I mean, okay, so again, we're dealing with some haze, but we're getting some nice moonbow effects from that, and I think this is a really cool picture, to be honest.
This is a really cool picture.
Even if it looks bad. Yeah. It's a cool picture, even though it looks bad. But this is the Crab Nebula.
It's not exactly the sort of thing you'd want to attach to a term paper, but it's really cool looking.
Hey, that looks great.
That's really good, yeah.
That's awesome.
You can see all kinds of different... So that's a cloud of stuff from this star that exploded. And then there's all of these weird, funky colors made by the moon hitting some atmosphere, the light reflecting off of the moon and then through the atmosphere and refracting in all kinds of weird ways.
Mm-hmm. In the center of this nebula, there is a neutron star, which is a very, very tiny star that spins pretty fast and is also, really heavy. So they're kind of weird.
Like a teaspoon of neutron star is heavier than the Earth, I think.
Who figured that out? What a weird measurement.
I don't know. Don't look at me. I think I heard that in a Kurzgesagt video one time.
Anyway, yes. Common weight measurements for this are taking a teaspoon and it weighing 10,000 tons or something. Very weird, very specific, but all you need to know is that it's really heavy. Made of entirely neutrons, basically. So
They're super weird. Sometimes when they spin really fast, they turn into magnetars, which means they have a really a really powerful magnetic field around them. And according to my E&M2 professor, John Gibbs, they can like rewrite chemistry around them because the magnetic field is so powerful that it changes what the permeativity of free space is.
That was a lot of big words.
It was a lot of big words. It make the elements do weird things.
I did not know that. That's really interesting.
Yeah, I didn't either. It was a thing that Dr. Gibbs just like offhandedly mentioned in a lecture last semester.
Hey, that's like solid
information. Apparently, they just have extremely powerful magnetic fields.
That checks out. Anyway, there's weird things in the universe that can do even weirder things. So
yeah,
let's
get weirder.
Yes, let's go to the moon because we have a request, and we should do this soon, I guess. So let's get it over with.
Moon time. Yep, before I destroy it.
I don't think the plane wave moved to the moon. Sorry, operator. Yeah, it didn't move.
Okay.
There we go.
Ooh.
There we go. Almost there. And we're changing the exposure time because the moon is so bright. Look at that. That looks
it's too reflective, and that's why I hate it. I will be destroying this rock as soon as the government gives me funding to do so.
I don't think they will, unfortunately.
I think that's quitter talk.
Okay. Anyway, let me just point out that the phase of the moon right now is a waxing crescent, and it looks pretty nice because we can see cool craters at the terminator line, which means the divide between the light and dark areas. It is arguably the most interesting way to view the moon, in my opinion.
Yeah, it's pretty cool. It's very pretty looking.
Yes. We are currently overexposing to try and look at Earthshine. Yeah, so we can
I love Earthshine.
Yeah, Wesley, explain.
Oh, there we go. Got a little bit of it there.
What is Earthshine?
There we go. So most of the moon's light is light from the sun that hits the moon and then is reflected back to us. The Earthshine is light that comes from the Earth and hits the moon and then is reflected back at us. And so it is extremely dim, especially compared to the rest of the moon. But during the kind of eclipse when the Earth passes between the sun and the moon,
a lunar eclipse.
You can just see thank you. I always think it's that, and then I get scared and I don't want to say it. I'm terrified of being wrong about which one is which. So during a lunar eclipse, you can see just the entire moon as Earthshine. It's really, really cool.
Yeah, it is really cool. We're basically projecting sunsets onto the moon, which is like kind of weird to think about, but that's what's happening. We had a question of, is Ceres close to the moon at the moment? And yes, Ceres is very close to the moon at the moment. However,
we also had a request for. Sorry, I'm just trying to get away from the moon as soon as humanly possible.
Well, let's go to Ceres because it's right next to the moon.
No.
Or we can try at least.
Charmed Chaos, you are welcome from the bottom of our beakers for bringing this to you. Myra Wells, I am glad you think that we are funny and beautiful. Thank you.
Let's see. We're doing some searching. Sometimes the Planewave catalog, we're using an online catalog for this, so like the program already knows where stuff is, and sometimes it doesn't have all the things. So we have to find other solutions to find certain objects. So we're going to try for this. Don't know if we're going to be able to get it, though, because it is pretty close to the moon. It looks like we are putting in coordinates for the telescope to go to, so numbers will be changing on the bottom of your screen. And that is us manually telling the telescope exactly where to go in the night sky. It's basically like a last resort thing. Putting in Orion deck is my least favorite thing, probably.
It stinks. Yeah.
It's probably because I'm lazy, but.
Hey, me too, man.
So it looks like We probably found Ceres because it's like on the plane wave interface. It looks really close to the moon, so we'll try.
No, so that's probably now. So the real difficulty here with something like Ceres is that we're going to turn this camera on, and just good luck figuring out which one of these points of light is Ceres.
You're right. Yeah, one of these dots is Ceres.
So here we go. One of those is Ceres.
I don't know which one.
I have no idea. I have absolutely no clue.
Take a guess, and you have a small percentage of being right. So.
Yeah.
So we have a
brighter ones. They're brighter usually.
I don't know. I don't think so.
No.
No, I don't know.
I mean, it's okay. Well, that's fair. I don't know either. I'm just throwing stuff at a dartboard. Hello from Canada. Sarko asks for M97. Can we get M97?
Wait, you skipped one. Yeah, let's go to M97.
Oh no, fooey.
But then
let's go to M97 first, and then we'll try the Clown Face Nebula afterwards.
Yes. But the wind is picking up a little bit, so if you have some objects that you are dying to see tonight, go ahead and put them in the chat because we want to be able to see them before the wind gets too pesky. So we're doing last call for objects at the moment. Just letting you know.
I'm going to try and speed run these last few so that none of our telescopes or the operators thereof get carried away by the wind.
Truly, I think the Geo Valley Open Deck Observatory, the GODO, as we say for short, which is where the telescope that we're currently using is like the windiest place and the coldest place in all of Flagstaff.
Ooh, that's a nice Clown Face Nebula. This is another planetary nebula. So got the big giant cloud of blue gas stuff. Owl Nebula?
This is M97.
Oh, God. I'm done. I'm very done. This is the Owl Nebula. I don't know anything. I asked for that. All right, this is the Owl Nebula. It's M97. It is a planetary nebula, and you can see the little tiny white dwarf in the center of it there. And it is a big giant cloud of gas that's mostly oxygen. I'll shut up now.
Hey, I think it looks great. Why do you think it's called the Owl Nebula?
I have no idea. I couldn't fathom a guess. Why is it called the Owl Nebula, Claire?
I don't know. I was asking you.
I don't know. I think it maybe like the dots are eyes. This is why I always get this one confused with the Clown Face Nebula in my head because they look similar-ish and like they're both like big clouds where there's some dots that are supposed to be eyes. I don't know. I don't know what I'm talking about.
Yeah. Let's go ahead and go to the Clown Face Nebula so we can have that comparison.
Yeah.
We have questions though.
Yes. K Pinecone Y. Does the wind affect things? Oh, sorry. K Pinecone. Why does the wind affect things? Good Lord. I'm just actively having a stroke right now. The wind affects things because it just sort of moves the telescopes, not in a massive way, but it's like obnoxious. It also means that the atmosphere above the telescopes is wibbly wobbly. So that can give you worse seeing, is what astronomers call it.
And right now, wind is about 20 miles per hour, which is like definitely enough to disturb the image that we're looking at, for sure. So that is the conditions. There's a question from Andy Larson. So about the Owl Nebula, it's named the Owl Nebula because we couldn't remember who found the nebula, so they walked around saying, who? That's funny.
No comment.
Okay, fine. This is the Clown Face Nebula.
It's really tiny.
It is. I don't see how you can mix up the owl and clown face. They look very different to me.
If you take longer exposures, I feel like they look kind of similar. Like the way that the clown, I don't know. I'm nuts, maybe. Maybe I'm just crazy.
This one definitely has like a more turquoise color, and it is brighter, in my opinion. Like less diffuse.
It is a little brighter, that's fair. It's brighter and a little smaller.
Yeah. But not too bad. So that's another planetary nebula. We've hit off a lot of good planetary nebulas.
Hold on, planetary. We don't have the Ring Nebula up right now, tragically. That's sort of the most picturesque of the planetary nebulas, in my opinion.
No, I think the dumbbell is the most picturesque.
You think the dumbbell's more?
Yes.
I mean, I guess. All right. I could.
You could see more detail in the dumbbell nebula.
Yeah, but it's like a weird shape. I don't know. I feel like the most like
dumbbell nebula.
All right.
Nebula.
Dumbbell nebula is very pretty. Is this a younger nebula than the Owl? Asks Dulcimerist. I think so, because it's smaller, and I think they spread out over time. But I would have to look at way more of the exact specifications of the sizes of this thing. But it looks a lot younger, for sure.
We have a question of, can we see the Big Dipper from where we are at? We can at the Dew Valley Open Deck Observatory, so our telescope operators currently can see it.
Can't see constellations through telescopes, though.
Yeah. Yes, we can see from the location of Flagstaff, Arizona, currently. So we had a request for Uranus, and it is currently too low for us to see, so we won't be able to get to that tonight. But
tragic.
Let's go to the Sombrero Galaxy.
All right. And I think unless we get any more requests, this will probably be our last object for the night.
True. But it's a good one to end on. It's spectacular.
It's a good one to end on. This is the first one that Vesto Slifer looked at through the Clark telescope and discovered redshift in.
Who is Vesto Slifer, Wesley?
Vesto Slifer is the acting director of Lowell Observatory after the death of Percival Lowell, our founder. He was a really cool guy.
Solid. Vesto Slifer also took care of Venus the cow. We had a cow at Lowell Observatory back in the day, and Vesto Slifer was the one who took care of Venus the cow, which is precious.
Aww.
So, good facts.
Good facts.
We're trying to get a picture of the Sombrero Galaxy. It looks like a sombrero, or like a flying saucer, or what else does it look like?
Looks like a frisbee turned sideways. Looks like a plate turned sideways.
No.
Looks like
what does it look like?
Looks like a galaxy.
Yeah, it does look like a galaxy.
Thanks, I'll be here all week.
This is totally weird, but this is what I imagine. Like, if I were to put something in the microwave that's not supposed to be microwaved, this is what I imagined what I would see, like, immediately.
Yeah.
Yeah. So.
Just explodes and there's a giant.
Yes.
Yeah. Mm-hmm.
Very true.
That's how microwaves work. Yeah. Yep.
Yes. Yeah. Don't know where that came from, but it's there. So this is a galaxy. We're seeing it kind of edge on, so we see that really nice thin disk. That's where all the gas, dust, and most of the stars are in this galaxy. And it's cool that we get to see it in this orientation. I think edge-on galaxies are my favorite, probably. They just look really cool, in my opinion. But that is the
yeah. All right. Andy Larson, we cannot see Saturn. I don't know who asked this, but we can see some stars in the Beehive cluster. And I do mean some. Beehive cluster is really, really big. And so we'll only be able to see one or two of the big, bright blue stars in it.
Yeah, let's go ahead and head over there, and I think that will be our last object for tonight. Probably. We're gonna look at the nice big stars.
Yes, the big stars. This is an open star cluster, so unlike that globular star cluster we were looking at earlier, these are much brighter, bluer, bigger, hotter stars. Dulcimerist, I have a fun answer and a not fun answer for your question. Are there any planets visible? Most are in that pre-dawn chain. A lot of them are pre-dawn right now. Venus is something that you can really only see either Venus and even more so Mercury are much easier to see right around when the sun is rising and setting. Oh, there was the not fun answer is that yes, you can see the Earth. It is visible directly below the horizon.
Terrible answer, but accurate. So
I am an incorrigible goblin.
oh, pretty good. So this is a portion of the Beehive cluster. This is a cluster that's easily viewable through a pair of binoculars. This is a really good one to start off with because it is really bright. Yeah, that's what I have with this cluster. Any comments, Wesley?
I have none whatsoever. They're big and hot and blue and bright and young. And that's open clusters.
Fair enough.
Younger stars.
Fair enough. Well, sweet. So
right.
we're gonna wrap it up. We want to thank you for coming to the interactive stargazing and interacting with us and seeing some cool objects with us. And thank you for joining.
Yeah, thanks for coming, everybody. Check out our podcast. It's Star Stuff Pod. There's a whole bunch of people on it. Yeah, goodbye.